Hello, everyone. You probably noticed I'm flying solo today because there's another name on that slide, Mike Gresham, a colleague of mine. Unfortunately, he couldn't make it to the conference. So I guess you're getting the director's cut version today of my slides. The good news is you don't have to sit through his bad jokes, but I can promise you the content is still great for today. First off, just a brief introduction to the company I'm working for. I'm working for NGS. It's an Australian-owned business. We offer a range of different GIS services, from advising clients on spatial technology, consulting in GIS services, building fit-for-purpose solutions, or provide training in the latest spatial geotechnology, whether that is enterprise or open source. So what am I talking about today? So this talk is about moving beyond buzzwords and into practical, impactful use of artificial intelligence in the GIS world. I'm going to explore, or we are going to explore, how cutting-edge tools, particularly QGIS plugins, are enabling faster, smarter, and more insightful geospatial work. And Mike and I, we handpicked some of the plugins and we'll showcase them today. So why does AI in GIS matter? AI is transforming GIS. You probably noticed over the last couple or 3 years, the field is shifting from manual digitization to intelligent classification and prediction. So you can scan thousands of square kilometers of high-resolution aerial photos or imagery to map every building footprint, power poles, solar panels, pools, you name it. AI enables a dynamic interaction with spatial data, unlocking new workflows and insights, real-time data analysis like disaster response, where real-time weather radar, flood gauge, sensor data, and social media feeds can be basically analyzed with AI within a few seconds or minutes, just by crawling through a damaged keyword, for instance. We think QGIS is the ideal open source platform, like a sandbox, if you like, for innovation and a tool for real-world AI deployment. So let's talk about some of the key terminology. These words, AI, ML, deep learning, LLMs, are often used interchangeably, but they represent distinct layers of capabilities. AI is more like the broad concept of building machines that can perform human-like intellectual tasks. And then we have machine learning, which is a subset of AI, enabling computers to learn from data commonly used in GIS for classification and predictive modeling. Then we have deep learning, a subset of machine learning, using artificial neural networks for advanced tasks like object detection or road on building extraction. And then we have LLMs we probably use most, it's an AI designed to process human-like language, useful for coding, querying, and autonomous GIS tasks. And think of ChatGPT, Gemini, Copilot, or Cursor. So why do AI and LLMs matter for geospatial professionals? AI and LLMs accelerate GIS work, shifting the focus from repetitive tasks to more strategic analysis. It comes with automation power. AI handles features extraction, pattern identification, and is even able to automate symbology, often via natural language prompts. LLMs act as intuitive, real-time GIS assistants, bridging basically the gap between technical tools and users. Outcome, you can work faster, you can reduce errors, and scale the capabilities basically of the human GIS analyst. So let's have a look at some of the QGIS plugin, or at the QGIS plugin ecosystem in general, in particular the AI and LLM tagged ones. So this is just an overview of the total plugin downloads recorded since July 24, and we reached close to 31 million. Looking at the dashboard, I mean, like I said, it's 31 million already. And already in February, March, there were another close to 60 plugins uploaded, and another 30 odd in April this year. And compared to last year, there's already an increase of 16% of total downloads of plugins. So you can see the plugin ecosystem is constantly growing. This graph is kind of interesting. So these are the plugins or plugin downloads of the 10,000+ downloads in September this year. And that was a total AI tag plugins of close to 850,000, which is roughly 3%, 2.7% of the total plugin downloads. We noticed, however, that some of the plugins aren't consistently tagged either with LM or AI or machine learning. It's quite a possibility that there are a few more plugins available. But we think the pools of AI and ML plugins are emerging, and we can definitely see there's a likely rise in these plugins in the coming or in the near future. So, like I said, we tested some of the plugins, and I'm going to showcase some of the selection now, starting with Bunting Labs AI Vectorizer, which is basically using the machine learning technology. So just to give you an overview and features with that plugin. So it basically automatically converts scanned or hand-drawn maps into vector layers using AI optimized for cartographic features. AI predicts and completes features from partial traces for faster, accurate digitizing. It supports line, polygons, and even stylized cut or cat line works like dashed or dotted lines. And it is a cloud-based AI tool, so there's no setup needed or dependencies. It's pretty much ready to go once you're signed up. So this is how it looks in action. So I downloaded a turbo or a raster map from Linz. Thank you. That's freely available. So once you created an account, you get a 7-day trial. After that, you have to buy a subscription. I think it was like $20 US per month for non-commercial use. So what I've done here is once you installed the plugin, you're pretty much ready to go. So you create your layer. Or you load an existing layer, select a target layer, start the edit mode, pick the plugin, and the magic happens by just basically tracing a line, and it's pretty amazing how it works. Once you're done, you save it down, and you start digitizing the next. So value proposition, it's obviously a massive time saving when it comes to digitizing. Thinking about it, back at uni, I needed to digitize kilometers of contour lines. I would have liked the idea of having a tool like this back then. There's no powerful hardware needed, but requires an internet connection. It handles both lines, polygons, and a variety of different map styles, like I said, dashed or dotted lines. That wasn't a problem for it at all to follow those lines. And like I said, there's also like a free trial available. But after that, there's a subscription required. Next one is MapFlow, which is also using machine learning technology in the background. This is working slightly different. So it converts any imagery, basically, to vector data using cloud AI. It can extract building, roads, and land features directly into QGIS. It works with public or commercial map service, but you can also load your own imagery if you want to. And it's also a subscription-based service. but you can also get some training. Well, as long as you stick within a small area, then that one is free. So once you sign up and created a token and you put the token into that tool, you're pretty much ready to go. Again, I used some imagery from LINS, downloaded some aerial or satellite imagery, uploaded it into Mapflow, and basically picked the area, just a small area around AUT, and wanted to extract the building of that area. So once the process is finished, so I set it all up and pick up the model, so I was interested in the buildings. Once the process is finished, you get an email notification, and then the results come in like this, which was actually mind-blowing, because within a few seconds I pretty much digitized all the buildings around the AUT area. However, you still need to check your data, because some of the outlines weren't 100% accurate. It gave me classification for the buildings. All of them were commercial, but still classification data, and also building heights. But like I said, I needed to double check the data and make sure everything was correct. Value proposition, automation obviously instantly converts raster into vector data, which is great. It's quite flexible. You can use your own imagery, or you use any web map services, which is also great. And it comes with specialized models and offers road, building, and footprint data extraction. Because there's obviously all sorts of other plugins, and I just wanted to mention others in that machine learning realm, if you like. Zaka classification tool, Nmap, Box3, ArcGIS calculator, and cluster points. Next one is Deepness, which uses natural network or neural network technology. It's a local AI powerhouse. You can use it for, or analysts use it and devs use it. It's open, it's flexible, and results are a lot faster and smarter. I just have to speed up. I just realized that I don't have much time left. In this example, we run a land cover segmentation model, which can be downloaded from the Deepness model Zoo. The model has been trained on 25 to 50 centimeter resolution satellite imagery. We used an image from Ponsonby, it's a suburb in Auckland. But because the model was created for Poland, you know, the results weren't as good. But regardless, the results in the videos show you an output for trees, water, roads, and buildings. But then again, unfortunately, the output color scheme doesn't highlight these very well, but then, you know, it's not a big deal. You can always go back there and classify your output. Deepness stands out because it nails the balance between power and simplicity. It's highly efficient, it's easy to access, functionality is great, it supports segmentation, classification, and detection with GPU acceleration. And cost, it's 100% free, which is great. It's totally community-driven. Other plugins, Deep Learning Datasets Maker, PyGIS, for instance, is also available. Next one, Q, the last one. Q is like having a smart GIS analyst built in QGIS. It's like your ChatGPT built in, which is great. It's like an AI co-pilot for QGIS. Boosts efficiency. It's very easy to use. It comes with a full feature set. It does analysis, cartography, data search, cloud sharing with flexibility, pricing. It's quite amazing. Just to show you how that works, once you sign up and you have that plugin loaded, in this example we tested and asked the following. So we loaded OSM data in, basically the whole world, and then we asked it, oh, zoom into New Zealand. And after that, we asked it, or zoom into Auckland Airport. After that, we said, well, just calculate the distance between the airport and Auckland. And once we've done that, we asked it also find the closest petrol station and also find the 5 closest restaurants to AUT. And it did it all within seconds, and it was amazing. Pretty impressive. And someone with little knowledge how to use a GIS like QGIS can pretty much work with an assistant like that rather seamlessly. Q really shines across all 4 of these dimensions. It's efficient, it's easy to access, its functionality is quite easy to use. Cost, it offers a scalable subscription plan, and overall it delivers major productivity and capability gains for any GIS workflow. Other plugins, QChat-GPT, I know, QGPT agent and Promptly, for instance, they are also available. Conclusion. With all the innovation we've seen so far, it's important to ask, what does this do for GIS professionals? The answer, it saves a heap of time, expands access, and enhances collaboration. Meanwhile, natural language interfaces like Q lower the barriers to entry for analysts who don't write code or know QGIS deeply. So we think this isn't just about new tools, it's about enabling new ways of working. So what are the core challenges of AI and GIS? Opacity. Many AI tools lack transparency, delivering results without explaining how they were actually computed. Data reliability, applying models trained on irrelevant or outdated data. Accountability, AI results need to be checked carefully, just like any other vital part of your work, actually, which we do anyway, every day. Practical friction points with AI and GIS. Some of them are quite difficult to set up. It's poor usability. Some plugins use unfamiliar user interfaces within their tool set. And broken workflows, switching file formats or waiting for asynchronous cloud-based results can be a bit cumbersome. Broadening impact of AI in GIS. AI tools in GIS are moving from experimental to operational, we think anyway, with adoption across diverse sectors, like city planners could use Vectorizer or Mapflow to streamline map digitization or zoning. NGOs and conservationists could use deepness for monitoring landscapes and habitats. Academia could use AI plugins like Q, which are transforming GIS education and allowing students to explore data intuitively instead of memorizing really difficult steps in between. Just in summary and outlook, current impact AI and LLM tools are actively helping planners, researchers, and analysts to work faster, collaborate better, and uncover new insights. But we have a responsibility, meaning adoption requires new standards, focus on transparency and clarity, and respect to data, privacy, and local knowledge. Good news is, we think anyway we are early in this journey and have the time to actively shape the evolution of these technologies to build a trustworthy future for GIS. Thank you.
Thank you very much, Pierre. That was very interesting. Do we have any questions?
Thanks. Was Q using, was it sending any context or embeddings to whatever LLM is behind it? Or was it, and so was the LLM doing the calculations of the distance with generic information that it has, or was it using QGIS tools to do that?
As far as we understand, it uses the built-in geoprocessing tools in QGIS. So it basically translates your prompt and then runs the geoprocessing tools in the back end from QGIS and actions it. As far as we understand it, anyway.
I have a question for you.
Mm-hmm.
With my experience with LLM tools, mostly for programming, I've seen that it's often the case with lots of tools that the first impression is, wow, this is great, this saves me so much time. But then you start using it a little bit and you realize, actually, a lot of the time it gets it wrong. I need to redo it. I need to double check everything. It's not really saving me that much time.
Yeah.
Did you notice something like that with these QGIS LLM tools? Or?
100%, I agree. I myself, to be honest, I'm not a coder, but I use LLMs a lot just to come up with, small scripts. And I heard someone was saying to me, a non-coder makes you actually a bad coder by using LLMs, because obviously I don't understand how to start a script from scratch. But to come back to your question, I mean, you always have to check your data anyway, which you should do. You shouldn't trust a system like this just blindly. And we noticed as well, and I think I touched on it on some of these tools, sometimes the outputs weren't 100% correct. So you had to go back and actually tidy up the data a bit. But the first task, like just to get for instance, footprint of buildings, I mean, that was obviously a nice step ahead, and then, the cleanup comes after that.
Thank you. Any other questions?
I think it's kind of more of a statement, actually, but I think what's going to happen is it's going to expose the lack of metadata in data sets. As I think about using AI on your own data, and frankly the state of our metadata in my organisation, using that tagline, AI is like a new intern, fast, enthusiastic, and sometimes completely wrong. It's like kind of bringing in an intern but not actually giving them any documentation or background of what your data actually is. So
yeah.
You can't expect it to really understand it.
Yeah. Although I guess you could probably train your own LLM with your own company policies and documentations, could you? I think that should work.
Yeah, sure. You could, but I guess it always relies on good metadata. So actually can understand it. Yeah.
Okay, thank you very much, Pierre, again, for your talk.
Cheers. Thank you.